Good morning, students. Exercise 6.5 second problem. Show that the lines r vector is equal to 6 I cap plus j cap plus 2 k cap plus s into I cap plus 2 j cap minus 3 k cap and r vector is equal to 3 I cap plus 2 j cap minus 2 k cap plus t into 2 I cap plus 4 j cap minus 5 k cap are skew lines, and hence find the shortest distance between them. Okay, so the given two lines we have to show they are skew lines. So skew lines, how it should be, they are neither parallel nor intersecting. Okay, so first we are going to say the given two lines are parallel lines. They are not parallel lines. So to check whether they are parallel or not, you have to see the parallel vector. So see, take the first line. The vector written along with the parameter is called the parallel vector. So you take this vector I cap plus 2j cap minus 3k cap and name that as B vector. Go to the second line and take the vector along with the parameter. So that is 2I cap plus 4j cap minus 5k cap. That is called as D vector. And you see B vector and D vector. You consider B vector, it is not a scalar multiple of D vector. Okay, so we can't write one vector is not a scalar multiple of other vector. Okay, so the two vectors are not parallel. If the two vectors are not parallel, the given lines are not parallel. So here we have proved they are not parallel lines. Next you have to check whether the given lines are intersecting or not. Okay, so for that, from the line equation, so this vector is A vector. Already we have noted this is B vector. Come to the second line, this is C vector and this is your D vector. So I have written A vector, B vector from the first line and C vector, D vector from the second line. A vector, C vector, they are the position vector of the passing point, and B vector, D vector are parallel vector to the lines. So now we have to check whether the given lines is intersecting or not. So you have to go for the condition for two lines to intersect. What is it? It is box product of C vector minus A vector, B vector, D vector, it is equal to 0. Otherwise this can be written as C vector minus A vector dot B vector cross D vector is equal to 0. So it is, I have taken as a box product. Box product value is 0 means the given two lines are intersecting lines. So I'll consider the left hand side box product of C vector minus A vector, B vector, D vector. So how to evaluate the box product? It is nothing but the determinant. So in the first row you have to write the components of C vector minus A vector. So C vector can be taken as x2, y2, z2 and A vector is x1, y1, z1. So C vector minus A vector components are x2 minus x1, y2 minus y1, z2 minus z1, and B vector is b1, b2, b3. D vector components are d1, d2, d3. So you have to substitute the values. So see that C vector x2, that is 3 minus 6. Next y2 is 2 minus 1, and here minus 2 minus 2. So that is minus 2 minus 2. Here b1 is 1, b2 is 2 and b3 is minus 3. So your d1 is 2, d2 is 4 and d3 is minus 5. So you have substituted. So 3 minus 6 is, what is that? It is minus 3. And 2 minus 1 is 1. Minus 2 is minus 4. Okay. So when you evaluate expanding by R1, you will get the answer as minus 7. So minus 7 is not equal to 0. So the box product of C vector minus A vector, B vector, D vector, it is not equal to 0. So therefore the given lines are not intersecting lines. So already we have proved that the given lines are not parallel lines. So therefore the given lines are skew lines. So now we have to find the shortest distance between them. It is asked. So here you are going to write the formula. So what is the formula? It is modulus of box product of C vector minus A vector, B vector, D vector divided by modulus of B vector cross D vector. Okay, so in the numerator we have found, okay, that is minus 7. So we have to find only the denominator. So before writing the absolute value, that is modulus, first you have to find out B vector cross D vector. Okay, so you have to evaluate the cross product. So it is also a determinant. In the first row you have to write I, J, K. In the second row B components, and the third row you have to write the components of D vector. Okay, so while you are expanding, you will get the answer as 2i cap minus j cap. Here you have to find the modulus. So modulus of B vector cross D vector is nothing but square root of 2 the whole squared is 4 plus minus 1 the whole squared is 1, that is equal to root 5. So substitute in the formula. The numerator answer is minus 7 and the denominator answer is root 5. It has to be written within the modulus. Modulus of minus 7 is 7. 7 by root 5. Distance cannot be negative. So that's why here in this formula we have written the modulus. Okay. So we'll come to the fifth problem. Show that the straight lines x plus 1 is equal to 2y is equal to minus 12z. And x is equal to y plus 2 is equal to 6z minus 6 or skew, and hence find the shortest distance between them. Okay, here the equations are given in the Cartesian form. The previous problem it is in the vector form. Here the equations are in the Cartesian form. So if the equations are in the Cartesian form, you have to check whether they are written in the correct format of the line. Okay, you consider the first one. X plus 1, here you is equal to 2y is equal to minus 12z. So this can be written as x plus 1 by 1 is equal to y by 1 by 2 is equal to z by minus 1 by 12. To avoid fraction, you have to consider the LCM of 2 and 12, that is 12. So the denominator has to be multiplied by 12. So 1 into 12 is 12. 12 by 2 is 6. Minus 12 divided by 12 is minus 1. So we brought the format of the line, and we are avoiding the fraction also. So from this, if it is the line equation, we have to find the vectors. So because the shortest distance is asked, so we can go for finding vectors. So first A vector. A vector is nothing but the position vector of the passing point. So the passing point, it has to be taken from the numerator. So Ax minus of minus 1. So the minus 1 is a one coordinate of the passing point, and here y alone is there, so it can be written as y minus 0, and here z minus 0. So therefore the passing point is minus 1 comma 0 comma 0. So you can write as a vector A vector. So minus 1, while you are writing vectors, it is minus I cap. And from the denominator, it is the direction ratios of the parallel vector. So B vector is equal to 12i cap plus 6j cap minus k cap. So first line over. From the first line we have found A vector and B vector. So take the second line and arrange x by 1 is equal to y plus 2 by 1 is equal to, from the third 6z minus 6. So from this you just take 6 out, and that 6 has to be written in the denominator of the denominator. So here your answer will become z minus 1 by 1 by 6. To avoid fraction, so the denominator has to be multiplied by 6. So x by 6 is equal to y plus 2 by 6 is equal to z minus 1 by 1. Okay, so from the numerator you have to take the passing points. Okay, so here x is there, so x minus 0. Okay, here y plus 2, this can be written as y minus of minus 2, and here you are having z minus 1. So the point is 0, minus 2 and 1. Okay, so C vector is minus 2j cap and plus k cap. Okay, so the line, the numerator form, how it should be, x minus x1, numerator form, x minus x1 is equal to y minus y1, z minus z1. So from that I have taken the C vector, and from the denominator you have the D vector is 6i cap plus 6j cap plus k cap. Okay, so I have from the two lines I have taken the 4 vectors. So now what you have to show, the given straight lines are skew lines. So we have to check whether they are parallel or intersecting. So you just consider B vector and D vector. They are not the scalar multiple of one. One vector is not the scalar multiple of other. So they are not parallel vectors. So therefore the given lines are not parallel lines. Next you have to check whether the given lines are intersecting. So what is the condition for two lines to intersect is the box product of C vector minus A vector, B vector, D vector is equal to 0. So this can be evaluated as x2 determinant x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3. Okay. So x2 minus x1, that has to be taken from C vector and A vector. So see that here only it starts with j component. So the I component is 0. So it is 0. Next j component is minus 2 and k component is 1 for the C vector. And A vector components are here minus I cap. So it will be minus 1, 0, 0. Minus 1, 0, 0. So you have to do the subtraction. So I have changed the sign. So 0 plus 1 is 1 and minus 2 here you are having 1 minus 0 is 1. So therefore C vector minus A vector, here you can write that is x2 minus x1 is 1, y2 minus y1 is minus 2, z2 minus z1 is 1. Then B vector component. So here you are having 12, 6, minus 1. So here I have written. Next D vector. The components of D vector 6, 6, 1. Okay. While you are evaluating, your answer is 84. So it is not equal to 0. So from that, the given lines are not intersecting lines. Already we have proved they are not parallel lines. So therefore the given lines are skew lines. And what is asked? The shortest distance. So you have to write the formula. In this formula, the numerator we have found and we are going to find only the denominator. For that, first you have to consider B vector cross D vector. So you know how to evaluate the cross product. So while you are evaluating, you will get the answer as 12 I cap minus 18 j cap plus 36 k cap. So you have to find the modulus. So before that, so what is the common number here? 6 is common, so we can take it out. So here 2 I cap minus 3 j cap plus 6 k cap. Okay, now you are going to find the modulus. Okay, so modulus of 6 is a number. So modulus of 6. And here you are having a vector. How to find the modulus of a vector? It is a square root of 2 the whole square plus minus 3 the whole square is 9 plus 6 the whole square is 36. So modulus of 6 is 6 and while you are evaluating, this answer is square root of 49. So it is 7. So it is equal to 42. Substitute in the formula. So the formula is this. So the numerator answer is 84 and the denominator answer is 42. So 84 by 42 is equal to 2. So in this way you have to find the shortest distance between the skew lines. Now we are coming to the fourth problem. Show that the lines, okay, look at this, x minus 3 by 3 is equal to y minus 3 by minus 1, comma, it is not equal to, it is comma, z minus 1 is equal to 0. Both are given separately and this term is given separately. And x minus 6 by 2 is equal to z minus 1 by 3, comma, y minus 2 is equal to 0. Intersect. Now you have to show that these two lines intersect. Also find the point of intersection. Okay, you consider the first line. So it is x minus 3 by 3 which is equal to y minus 3 by minus 1. Here in the problem it is given comma. Now I am going to write equal to. So you see that here from this problem z minus 1 is equal to 0. Okay, you are getting z is equal to 1. Okay, z is equal to 1. So that can be written as z minus 1 by 0. So denominator if you write 0, that answer the numerator is equal to 0. If you write the denominator is 0 means the numerator value is equal to 0. So the numerator is what? Z minus 1 is equal to 0. So this can be written as which is equal to Z minus 1 by 0. Okay. So consider this next line. So x minus 6 by 2 is equal to, here what is it? It is comma, it is given y minus 2 is equal to 0. So the numerator is y minus 2 and the denominator is 0. So y minus 2 by 0 which is equal to z minus 1 by 3. So from these two lines you have to take what are the vectors? A vector, B vector, C vector and D vector. A vector has to be taken from the numerator. So how the line form should be in the numerator? X minus x1, y minus y1, z minus z1. So therefore the point is 3, 3 and 1. So the vector is 3i cap plus 3j cap plus k cap. Okay, and the denominator or nothing but the direction ratios of the parallel vector. So B vector is equal to 3i cap minus j cap. The same way C vector will be 6i cap 2 plus 2j cap and plus k cap, and the denominator D vector is equal to 2i cap plus 3k cap. So what is asked? Show that the lines intersect. So you have to go for the condition for two lines to intersect. So it's a box product of C vector minus A vector, B vector, D vector is equal to 0. This how it will be evaluated using this formula. What is the determinant? x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 is equal to 0. Okay. So see now, what is x2? x2 is 6 here. x1 is 3. So 6 minus 3 here it is written. y2 minus y1. Come to C vector, y2 is 2 and here it is 3. So 2 minus 3. And come to z2 minus z1. z2 is 1 and here it is 1. So 1 minus 1. So b1 has to be taken from B vector, that is 3. Next one minus 1. So no k is here, so it is 0. Come to the D vector, components is 2, 0, 3. What is it? 2, 2, 0, 3. 2, 0, 3 here. Okay.
2, 3.
6 minus 3, that is 3. 2 minus 3 minus 1 and 1 minus 1 0. So the second row is 3 minus 1 0, 2 0 3. Look at the first row and the second row, they are identical. So therefore the value of the determinant is 0. So the box product of C vector minus A vector, B vector, D vector which is equal to 0. So therefore the given lines intersect. So they are intersecting lines. Okay. So what is asked? Also find the point of intersection. So we are going to find at what point the two given lines intersect. So for that you consider the first line and which is equal to T, and you are going to find a point on this line. Okay, so you have to find what is x, what is y and what is z. You take the first term x minus 3 by 3 which is equal to t. So the denominator 3 into t, 3t, minus 3 when you take it to the right side it will become plus 3. So you are getting x is equal to 3t plus 3. Similarly, take the second term and equate to t. So the denominator minus 1 when it is multiplied with t it is minus t, and minus 3 when you take it to the right side it will become plus 3. So y is equal to minus t plus 3, and come to the z minus 1 by 0 is equal to t. So 0 into t is 0, so z is equal to 1. Okay, you consider the second line and which is equal to s, and you are going to find a point on this line. Okay, so the same way you have to proceed. So x has 2s plus 6 and y 0 into s 0 minus. So any point on this line is of the form. Okay, so we have to find x, y, z. So take this term and equate to s. So x minus 6 by 2 is equal to s, So 2 into s is 2s, minus 6 when you take it to the right side it is plus 6. So x is equal to 2s plus 6. And come to y minus 2 by 0 is equal to s. 0 into s is 0. So y minus 2 is equal to 0. So y is equal to 2. And come to z minus 1 by 3 is equal to s. So z minus 1 is equal to 3s. Z is equal to 3s plus 1. So after finding the point on this line, so at the point of intersection, the both points are same. Okay, so you will get at the point of intersection, you will get a single point. So we are equating the coordinates of the both the points. So 3t plus 3 comma minus t plus 3 comma 1, which is equal to 2s plus 6 comma 2 comma 3s plus 1. You have to equate both the points. Okay, so the x coordinate has to be equated. So 3t plus 3 is equal to 2s plus 6. In the same way, y coordinate minus t plus 3 is equal to 2 is and 1 is equal to 3s plus t. Okay, so when you bring this s to the next side, it will become minus 2s. So the number in the right hand side is 6 minus 3, that is 3. And come to here, this 3, when you take it to the right side, it is minus 3. So 2 minus 3 is minus 1. Minus 2 is equal to minus 1. So t is equal to 1. At the next one, 3s. This plus 1, when you take it to the left side, minus 1. So 1 minus 1 is 0. So 3s is equal to 0 means s is equal to 0. Either you can find t or s. So these t and s or any one has to be substituted in the corresponding point. So I'll take s is equal to 0. When I substitute here, you see that the point is 6, 2, 1. That is the point of intersection. Suppose if you take t is equal to 1 and you have to substitute here. So what has to come? Here 3 plus 3, 6. And here you will have minus 1 plus 3. What is minus 1 plus 3? That is 2. Okay, and here it is 1. So therefore the point of intersection is 6, 2, 1. Okay, come to the third problem. If the two lines x minus 1 by 2 is equal to y plus 1 by 3 is equal to z minus 1 by 4 and x minus 3 by 1 is equal to y minus m by 2 is equal to z intersect at a point, find the value of m. So what is given? The two lines or intersecting lines, they intersect at a point and you are going to find the value of m. So the condition for two line to intersect is box product of c vector minus a vector, b vector, d vector is equal to 0. So in the Cartesian form or evaluating the box product, you can write x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3, which is equal to 0. So we have to find a vector, b vector, c vector and d vector. Okay, so see now a vector has to be taken from the first line. So it has to be taken from the numerator. Okay, so see that before that you have to check whether the given lines are in the correct form. So here x minus x1, so 1 we can take. This can be written as y minus of minus 1. So we have to take the point minus 1 here. And z minus 1. So you have to take 1. So therefore the point is 1 comma minus 1 comma 1. Either you can write x1, y1, z1 or you can write it in the vector form. So a vector is equal to, what is it? I cap minus j cap plus k cap. And the denominator or nothing but the direction ratios of the parallel vector. So b vector can be written as 2i cap plus 3j cap plus 4k cap in vector form. In the Cartesian form, you can write b1, b2, b3 as 2, 3, 4. Okay, come to the second line. You check whether it is in the correct form. After checking that, you have to see the numerator and the points are 3, m, here it is 0. Okay, z only is here. It is equal to z, not comma. So it is equal to z. So the z can be written as z minus 0 by 1. Okay, so the point is 3, m, 0. So it can be written as vector 3i cap plus mj cap. and see the denominator. So here you are having 1, here you are having 2, here in the denominator it is equal z by 1. So therefore the D vector is I cap plus 2j cap plus k cap. Okay, and you can write C vector as x2, y2, z2. This is the passing point. A vector and C vector are the position vector of the passing points. Okay, B vector, in the Cartesian form we can write b1, b2, b3. The D vector d1, d2, d3. Either you can use this or you can use this format. Okay, so first one implies we have to substitute x2 minus x1. What is x2? 3 minus 1. So I have written here. Next one, y2 minus y1. So m minus of minus 1. So m plus 1. And next z2 minus z1. So 0 minus 1. Okay. So b1, b2, b3 is 2, 3, 4. d1, d2, d3 is 1, 2, 1. That is equal to 0. So 3 minus 1 is 2. M plus 1, 0 minus 1 is minus 1. So you have to expand by R1. So while you are expanding, you have to see the second term. You have to change the sign. So here I have written minus of m plus 1. Delete the first row and the second column. So it is 2 minus 4. Okay, you have to expand by R1. So here you are having minus. So the minus has to be applied to both the terms. So that's why I have written minus m minus 1. The 2 minus 4 answer is minus 2. So minus 2 into minus m is plus 2m and minus 2 into minus 1 is plus 2. So the remaining has to be evaluated. So here the final answer 2m and 2 minus 1 is 1. So minus 10 plus 1 is minus 9. So 2m minus 9 is equal to 0. So 2m is equal to 9. M is equal to 9 by 2. Thank you, students.